To study guide forum. Today we are going to enjoy volumetric analysis. And this volumetric analysis, the question said that here is a solution containing 5 grams of sodium hydrogen tetraoxosulphate 6 per gm cube. B is a solution of sodium hydroxide containing S gram of sodium hydroxide per gm cube. Now the instruction in the practical, this is a practical question that A, put A into the burette and titrate 25 or 20 cm cube of B with A using methyl orange as indicator. Record the volume of your pipette. Tabulate your burette readings and calculate the average volume of A used. Average volume of A required to neutralize the stated volume of B. The B question there said that from your results, calculate the concentration of A in mole per dm cube and the value of X. The equation of reaction is what we are given here, and the relative molecular mass and atomic masses of the sodium and sulfur and the rest of them are there. So what we're going to do here, we'll after the titration, we'll start from the table. So this is what we have from the table. The volume of pipette is 25 cm cube. Indicator used in methyl orange, and then we find out that final reading. This is our final reading, initial reading. So when we subtract, we'll find out the average volume of A used is what we have here. Then we use the one that are very close together well, then to get our average. By adding them, we get this. So from there, we can continue with the calculations that they say we should do here. In this calculation, they said that we're going to find what the concentration of A in mole per dm cube. Concentration of A in mole per dm cube. That means to do that, let's keep our average volume as it's somewhere here. Let's keep it here. So the average the concentration of A in mole per dm cube will then give us, we know that the gram will have a mass of A is what, 5 grams, and the molar mass of A is equal to 120 gram per mole. Now how do I get this? We know that this other one, sodium, so based on that, sodium is 23 plus hydrogen plus sulfur, which is 32, plus 4 times 16, we have 64. All of them will give us 120 gram per mole. That's how we got that. So, and then to calculate the mole concentration, and then mole, sometimes we call it amount. Amount is equal to what? Mass over molar mass. So the mass here, the mass is what? 5, and then the molar mass is 20. Then it will give us, what we'll get there will be 0.042 mole. Now we know that concentration is always amount over volume, and our volume here, volume is equal to 1 dm cube. So our amount, which is 0.042 divided by 1, will give us 0.042 mole per dm cube. That is what we have our concentration. Now that's the concentration of this A in mole per dm cube. We have it there. This is always dm cube. All right, let's continue. with that in mind, and also keep it somewhere here. Also keep it here. So we can go ahead now. So we can use this formula. This is a formula we're going to use. We know that Ca is the concentration of A, which is 0.042 mole per dm cube, and volume of A is 24.5 cm cube, and volume of B is 25 cm cube, and concentration of B we don't know it. We can say unknown, so it's unknown. And now our ratio of this will be A and B. Our ratio here is 1, and the other one is also 1, based on this chemical equation. This chemical equation, now you see that sodium hydrogen tetraoxosulphate 6 is 1, this other one is also 1, and then so that means the ratio of 1 is to 1. In that case, now we can substitute. If we substitute, we have our A to be 0. Concentration of A to be this time volume, which is all over the concentration of B, which we don't know, times volume 25 equal to 1 is 1. So when we cross over, this will give us 25 times 1 times CB will give us 0.042 times 24.5. So C would give us then CB, that's the concentration of B, will then be 24.5 all over 25 times 1. That will give us 0.0041 mole per dm cube. That is what we have here. So now the next thing we are going to find is the value of X. The value of X. To calculate the value of X, the value of X we have it to be, since we know that 1 mole of sodium hydroxide will contain 40 grams. Now, why is this 40 grams? Why do we choose 40 grams? Because the molar mass of sodium hydroxide is 40. Now 40 grams can, well, since you are working with, we're trying to find the gram too, we can also look at it, consider it as also the gram, because the mole per dm cube, gram per mole. In each mole, note in each mole, say that our molar mass is what? Gram per mole. That means in one mole we have what? The gram in question. This one is gram per mole. You understand? That means in 1 mole we have what? 40 grams. In 1 mole we have what? 40 grams, gram per mole. Now I want us to keep that thing in our mind anytime we want to do calculation based on that. So that means in 1 mole of sodium hydroxide it will contain what? 40 grams. That's why we say it's gram per mole. Alright. Then this other one we have 0.041 mole of sodium hydroxide. So in this case now, what will this one contain? If 1 mole contain 40, that will give us 40 over 1 times 0.041 divided by 1. Then our final answer will then be 1.63 grams. For 1.63 grams, that is what we have. But I hope you enjoy our class today, and I want you to enjoy more by subscribing to our channel, and then leave your comments, share. Thank you so much.